right, let's learn a couple of new vocab words real quick before we start solving some applications. 2 new phrases. First new phrase is called angle of elevation. Second new phrase is angle of depression. It has nothing to do with sadness. The angle of elevation is the angle made by your line of sight to the horizon, which is parallel to the ground, and your line of sight looking up to an object. So if I were to do a little doodle, imagine a little person, okay, and they're looking up at the sun in the sky. Here's the sun in the sky. So the angle of elevation is their line of sight, this way, looking up to the object. This is the angle of elevation. Angle of elevation. Angle of depression is similar but different. Angle of depression is the angle made, again, still by your line of sight, which is parallel to the ground, but this time it's looking down to an object. So angle of depressions are usually when someone is like on the top of something looking down. So imagine you are standing on a cliff. Here's you on a mountain, okay? And you spotted a cheetah on the ground. Here's a cheetah. And you're like, let me measure the angle of depression to it. So it's your line of sight, which is parallel to the horizon. That's a cheetah. That is a cheetah. Looking down to the object. This would be an angle of depression. Guess what's also depression? That cheetah. Depression, not depression. Depression. We're going to need to know these 2 words because often on Trig application problems like this, it does not necessarily give you a diagram. You have to draw your own diagram and then use that diagram to answer some questions. First one, it's about the office. Michael, he's standing on the edge of the office roof. I don't know if you remember this episode, but he gets really depressed because the warehouse workers make him feel like his job is super easy, and so he's trying to show them it's not easy, that there's a lot of mental anguish. So he's on the top of a building, the office building. Okay, so Michael's up here, and he's looking down at Dwight. Dwight's on the ground with a microphone. Okay, here's Dwight on the ground. He's standing with a megaphone in a parking lot. The angle of depression from Michael to Dwight is 42. We can draw that in. From Michael to Dwight. Okay, so that's our line of sight looking down to Dwight is 42 degrees. Okay. And then we're also told Dwight is 20 feet from the wall of the building. So here's our building. Okay, so Dwight is 20 feet from the wall. That's this distance right here. 20 feet. Okay, and then what are we asked to find? How tall is the office building? How tall is the office building? Which would basically be this side right here that we're trying to find. Now, do you kind of see how we built a little right triangle? Everyone kind of see the right triangle? I'm going to highlight around it so we can kind of see it. We got this one, and this one, and this one. Now, if this angle is 42, what is this one?
48. That one. Wait, that one.
If this angle is 42, what is this angle?
42.
Also 42. Good job. Anyone know what those were called? Any memory of that from geometry? Alternate interior angles. Oh my God, Mr. Caden would be so proud of you. Yes. Okay. Now, on this right triangle, if we are trying to find the height of the building, let's look at that. From this angle that we're referring from, we're trying to find its opposite side, and we know its adjacent side. What trig ratio pairs opposite side with the adjacent side? Tangent. Yes, tangent pairs opposite with adjacent. Okay, so I'm going to just write down tangent of the angle, I'm going to call the angle theta, equals opposite over adjacent. Just reminding myself what that trig ratio is. Opposite over adjacent. Okay, I'm going to fill in what I know. Okay, what was the angle again? 42. So tangent of 42 degrees equals, do I know the side that's opposite from it? No, I'm going to put a variable. I'm going to just use x. Do I know this side that's adjacent to the 42 degree? What is that one? 20. And it kind of creates a little equation that we need to solve. What would be my one step to solve this equation? Multiply by 20. Okay, so the height of the building will be found by doing 20 times the tangent of 42. Again, please make sure that your calculator is in degrees since this angle is in degrees. 20 times the tangent of 42. Approximately 18 feet. Yes, if we want to round to 18.01 feet, that's okay. I'm going to say it's about an 18-foot tall building. If he jumps, will he break his leg?
Yes.
Probably. He won't die, but he'll probably break his leg. All right, let's look at another one. All right, lighthouse, ship at sea. A ship at sea sights a lighthouse on the shoreline. Here's our lighthouse on the shoreline. The navigator measures the angle of elevation from the water line to the top of the lighthouse and finds that it's 17 degrees. Okay, so I'm going to draw the ship out here. It's very, very shippy. There it is. Got a little one of these. Okay. So again, the navigator measures the angle of elevation from the water line to the top of the lighthouse. Here's our water. To the top of the lighthouse. I'm going to use a ruler just to make it straight. Y'all don't have to make it straight, but you know, I'm weird. Water line to the top of the lighthouse. And he says this angle of elevation measures how much? 17 degrees. Obviously not drawn to scale. The ship must stay 200 meters from the shore, or it risks running aground. If the lighthouse is 60 meters tall, is the ship a safe distance from the shore? Dang, Sally sells seashores from the seashore. That's a lot of S's. How tall is the lighthouse?
60 feet.
60. It's okay. Now, I don't want to write in a 200 right here, even though it says the ship must stay 200 from the shore. What I'm trying to figure out is, basically, is this greater or less than 200? Is it above 200? Is it less than 200? So I'm trying to solve for this side to figure out how close is that ship from the lighthouse to see if it's going to run aground or not. Now, again, we have kind of created ourselves a little right triangle. Okay, we know an angle. We know the side that is opposite from that angle, and we're trying to solve for the side that is adjacent. So again, we're trying to think to ourselves, what trig ratio pairs opposite side with the adjacent side? Tangent again. It's not always tangent. So I'm going to write down just the tangent ratio again. Tangent of an angle is opposite over adjacent. And then I'm going to fill in what I know. Do we know theta, the angle? Yes, it's 17. Do we know the side that's opposite? Yes. What is that one? 60. And the adjacent one is what we're trying to find, basically trying to figure out, is it more or less than 200? Now, unlike the last question we were like, multiply by the denominator, variable isolated. It doesn't work as well on this one. We can't simply just multiply by 60 and get 60 to cancel. What we can do instead to get at least the variable out of the denominator is multiply by x. Multiply by x. It doesn't fully solve it yet, but at least gets the variable out of the denominator. Now we have x times the tangent of 17 degrees. And then this one would have one more step to isolate x. Divide by tangent of 17. Okay, so let's see if that ship is at a safe distance from the shore. 60 divided by tangent of 17. Is it a safe distance from the shore? No, because it says it has to stay at least 200 meters from the shore, which means it needs to be greater than or equal to 200 meters. And it is not, which means what's going to happen? It's probably going to run aground. Not a safe distance. I actually think trig applications are a little easier than just like solving the triangle, which we did in the last lesson. Solving the triangle, I feel like it's just arduous. There's so many angles, so many sides, where if you're just solving an application, it's usually just one thing you're looking for. You're either looking for an angle or some sort of side. All right, next up, and then we have one practice AP question at the bottom. So this one's talking about we're on the observation deck at the Seattle Space Needle. Who's been there? Oh, really? Good job, guys. There's also a similar one in San Antonio. Anyone been to that one? The top of the space? There you go. Okay. It is 520 feet from the ground. It's high up. Okay, so we're standing on the top. Let's draw us in. Here we are. Ding. Standing on the Space Needle, acting reckless. We're looking out the windows, and we notice someone next to our car with a can of spray paint. So here's my car down here. Good luck drawing a car. There it is. And someone standing next to it with a can of spray paint. Got it. Okay. The angle of depression from you to your car is 68 degrees. Remember, an angle of depression straight from the front is our line of sight looking down to the object. So, drawing in my angle of depression from my line of sight on the top of the Space Needle, looking down to my car. And what is that angle of depression again? 68 degrees. Kind of drawn to scale. Okay. The car alarm button on your keychain has a maximum range of 600 feet. So we've got our clicker in our pocket and we're trying to see, can we click it and make it go off? That's what we're trying to figure out. But the maximum range is 600 feet. So the question is, can you activate your car alarm and startle the would-be graffiti artist into leaving your car alone? We were given one other piece of information that I did not label yet. What do I need to label? The height. What's the height of the Seattle Space Needle? 520 feet. So that is this height right here. Now let's figure out, I can see the little right triangle coming together, but we do need to figure out what are we solving for on this right triangle. Are we trying to solve for the leg, this bottom distance, or are we trying to find the hypotenuse? We are trying to find the hypotenuse. We're trying to find, can we click it from the top of the Space Needle and make the car alarm go off? Okay. So again, we had a question similar to this on the last notes. If my angle of depression is 68 degrees, what's going to be this angle in my right triangle? 68 degrees. Good. Okay, so looking at what we have an angle. We have the side that is opposite from it, and we're trying to solve for the hypotenuse. So we got to think, which trig ratio pairs opposite with hypotenuse? Sine is opposite over hypotenuse. Yes. Sine of the angle is opposite over hypotenuse. Okay, I'm going to fill in what I know. What did the angle measure again? 68 degrees. What did the opposite side from 68 measure? 520. Please in feet. Yes, feet. And then the hypotenuse is what we don't know. I'm going to throw in a variable. That's what we're trying to solve for. Okay, similar to the last one, I can't just multiply by 520 to isolate my variable. What I can do, though, is multiply by x, and that at least gets it out of the denominator. Giving me x times the sine of 68 degrees equals 520. And then I would still have to do one more step to isolate the x. Divide by sine of 68, yes. Okay, again, double check that your calculator is still in degrees. If you reset it, it'll go back to radians. 520 divided by the sine of 68 degrees. All right. So once we get the actual length, we can talk about whether our clicker will reach or not. What is the range of our clicker? 600 feet. So we're only 560 feet away. Is my clicker going to reach?
Yes.
It will. Get him. Yes, it'll reach. All right, one last question for the day. It comes straight from AP Classroom. You can see, I literally screenshotted it. Okay. Also, I feel like a lot of times on questions from like an AP test and stuff like that, they're not necessarily caring about the final answer, and you can actually see that on the answer choices. They don't care about the final answer. They care about basically how are you setting it up to solve for that answer. So we look at the question. It says Sanjay's designing a banner that is in the shape of an isosceles triangle. What's that? Two sides are the same. Good. I'm going to go ahead and mark them off. Two sides are the same, which means that the two angles would also be the same here, because if the two sides are the same, two angles have to be the same. To hang the banner the way he wants, the base of the isosceles triangle must have a length of 18, which he did label in the diagram. Length is 18. The area of the banner can be adjusted by changing the size of the base angles of the triangle. Which of the following functions, over here on the right, A, B, C, D, best models the area of the banner? Okay, so all of these functions stand for area of the banner in terms of base angle theta. And then they also did give you the formula for area. Area is base times height. That's nice, at least. They're making you do all this hard trigonometry, and then they still tell you the formula for area of a triangle. I feel like that should be the least of your worries. Okay. We know we have to do 1/2 base times height. Do I have all of those? No, I don't. Do I have any of those?
Yes.
Oh, yeah, I have base. Base is 18. What do I still need to find then? Height. Okay, we know we need to find height. I'm going to put a little question mark here for height. Okay. So if we think about the angle, here's our angle. We're looking for the side that is opposite of that angle. And technically, if we think about each of these as a little right triangle, do we know one of the sides on this right triangle?
The adjacent.
We know the adjacent side measures 9. Yes, very good. Okay, so we're looking for opposite when we know adjacent. Which trig ratio do we need for opposite paired with adjacent? Tangent. Okay, so again, our goal here is to kind of solve for height. So tangent of the angle equals opposite over adjacent. So I'm going to fill in what I know. Do I actually know what the angle measures? Did they tell me what it measures? All right, don't fill that in. Don't fill that in. So then we'll have tangent of theta. Do we know what the opposite side measures? No, but we can actually give it a variable. Technically, what part of the triangle is it? It's the height. So we could call it h for height if we want to. Over, do we know what the adjacent side to the angle measures? What is it? 9. Okay. So again, our goal here is we're trying to solve for height. We can take this little trig equation that we wrote and solve it for h. What would we need to do to solve for h? Multiply by 9. Multiply by 9. Okay. So the height is just 9 times the tangent of whatever the angle is. And we don't know what the angle is yet. But that's okay. If you look at all your answer choices, do they fill in the value of the angle? Do they fill in the value of the angle for any of them? No, so it really doesn't even matter. So now that we know that the height is 9 times the tangent of theta, do we have enough information to find area, which is 1/2 base times height? Yes. We do. Let's do it. So area equals 1/2 base times height. They already told us area is f of theta, which is just function notation. So f of theta equals 1/2 times the base. What is our base of the whole entire triangle measure?
18.
18. What is the height of the whole entire triangle measure? 9 times the tangent of theta. Now we can simplify a little bit of this. You can actually take the numbers and multiply them together. A half of 18 times 9. Yeah. Half of 18 would become 9 times 9 tangent of theta, which is 81 tangent of theta. Is that one of our answer choices for area? Sweet. So again, a lot of times on the AP test, they're not necessarily looking for a final answer. They're kind of looking for the process to get that final answer, which is what this one asks for.